Assalamualaikum and welcome back. Now let's continue with an example finding unit tangent vector and unit normal vector. So for that, let's look at tutorial 3, question number 6b. Okay, question number 6b, we have, okay, here we are asked to find unit tangent vector and unit normal vector at the given point for each of the following curves. Okay, for 6b, we're given a curve x equals et cos t, y equals et sin t, z equals et. So as you can see here, the curve is in xyz space, and they are given as a set of parametric equations, and we are asked to find unit tangent vector and unit normal vector of this curve when t is equal to 0. Okay, so here we have the curve given in a given in a set of parametric equation, and we are asked to find unit tangent vector and unit normal vector. Okay, so for unit tangent vector, the formula is equal to r prime divided by magnitude of r prime. Okay, so for r here, for our curve, r is equal to et cos t. So that is the x component, which is governed by the parametric equation for x. And for the y component, it's it's et sin t, and the z component is et. Okay, now we need to find r prime. Okay, r prime, remember before, to differentiate a vector function, you just differentiate the x component, the y component, and the z component. So when we differentiate the x component, we get, we're going to use product rule. So that's going to be et cos t plus et, and then differentiate cos t. So when you differentiate cos t, we get negative sin t. So we have minus here, sin t. And for the y component, again, we need to use the product rule. So we have et sin t plus, now we differentiate sine, we get cos t. And the z component, we get et. Differentiate et, we get et again. Okay. Next, we need to find r prime, magnitude of r prime. So magnitude of r prime, we need to find, we need to square all the components and then add them together and then take the square root. So this is going to be equal to, so we have to take the square of that. Okay, square the x component, so that's going to be et, so square that. So that's going to be e2t, and here I'm just going to write this as such. So we factor et out first and then square them, so we get e2t. Now sin t plus cos t, we need to square that. And then square the z component, so we have e2t. Okay. Next is, I'm going to simplify this. So here we have e2t, and here we have e2t and e2t there as well. So let's factor e2t out. Okay, now when we expand this, the first term, we get cos square t minus 2 cos t sin t plus sin square t. So that is the expansion of cos t minus sin t squared. Okay, now I'm going to do, let's do the same thing for the second term there. So when we expand sin t plus cos t squared, we get sin square t plus 2 sin t cos t plus cos square t. Okay, and here we have plus 1. It's a long one. And then take the square root of this. Okay, all right, now we can do some simplification here. All right, here we can see that we have 2 cos t sin t, and here we have 2 sine t cos t, so that will give us 0. Okay, and here we have cos square t plus sine square t, sine square t, that would be 1. And here we have another one, sine square t plus cos square t, so that is going to be another one. Okay, so simplify this, we get e to t square root. Okay, so here we have 1 plus 1 plus 1, which is really 3. So we have 3 e to t square root of that, which is really et square root of 3. So that is our magnitude of r prime. Okay, now we can get t, unit tangent vector t. So t, unit tangent vector t, which is r prime. So this is r prime. Okay, so r prime there would give us et cos t minus sine t. That's the x component, and the y component is sine t plus cos t, and the z component is et. Okay, then we're going to divide this with its magnitude, which is really et times square root of 3. Okay, now if we simplify this, you can see that we have et, and et, so we can factor et out. So what's left is cos t minus sine t for the x component, sine t plus cos t for the y component, and 1 for the z component. And here we have et times square root of 3. So et over et, that will give us a 1. Okay, so we end up with cos t minus sine t plus cos t, 1 divided by square root of 3. So this is unit tangent vector. So now we can get unit tangent vector when t is 0. Okay, when t is 0, then unit tangent vector is equal to, okay, cos at 0 is 1, sine at 0 is 0, and here we have 1 divided by square root of 3, or we can write this as 1 over square root of 3i, 1 over square root of 3j plus 1 over square root of 3 k. So that is unit tangent vector at t equals 0. Okay, we are also asked to find unit normal vector. Okay, so for unit normal vector, I'm gonna copy this to the next page. Let's see. So we need this. Okay, let's copy that to the next page. Okay, so for unit tangent vector, unit normal vector, we need to use the formula. Okay, remember the formula for unit normal vector is here, is equal to t prime divided by magnitude of t prime. Okay, so here we have unit tangent vector t. Alright, so now we need to differentiate, and then we also need to find the magnitude, and then we're going to replace t with 0 so that we get unit normal vector when t is 0. Okay, let's find t prime. So for t prime, we need to differentiate t. So here we have a constant 1 over square root of 3. I'm going to write it down here. Okay, and then just differentiate the x component, the y component, and the z component. Okay, differentiate the x component, we get negative sine t minus cos t. The y component will give us cos t minus sine t, and the z component will give us 0. So that is t prime. Okay, now we need to find magnitude of t prime. So for magnitude of t prime, we need to square the x component, the y component, the z component, add them together, and then take the square root. Okay, so we have a square root here. Okay, now square the x component, so that would give us negative sine t minus cos t square over 3. And here we have cos t minus sine t. We need to square that as well. So square of 3, we get 3 and 0. Okay, now simplify this. We get sine square t minus 2 sine t cos t plus cos square t over 3. Okay, and the second term we have cos square t minus 2 sine t. Wait, this one is plus, sorry. Minus 2 sine t cos t plus sine square t over 3, and of course we have a square root there. Okay, now we can simplify this. Here we have 2 sine t cos t over 3, and here we have negative 2 sine t cos t over 3, so that will give us a 0. And then we have sine square t plus cos square t, so that would give us a 1. And here we have cos square t plus sine square t, that would be a 1 as well, so we have 1/3 plus 1/3 square root of that, so we have 2 over 3, square root of 2 over 3. So that is t prime. So now we can use the formula. So the unit normal vector, which is equal to t prime, so this is our t prime. We have 1 over square root of 3. Here I'm using the pointy bracket, minus cos t minus sine t, 0, okay, divided by its magnitude, which is 2 over 3, square of that. So simplify this, we get negative sine t minus cos t over square of 2. For the y component, we have cos t minus sine t over square of 2j, and for the z component we get a 0. So that is unit normal vector. So now we can find the unit normal vector when t is 0. So when t is 0, replacing t with 0, we get negative 1 over square of 2i, and here we have 1 over square of 2j and 0k. So this is our principal unit normal vector. And remember from before, we know that unit tangent vector and unit normal vector are perpendicular to each other. Okay, so remember this, right? Because n is parallel to t prime, but t prime and t are orthogonal, which means n and unit normal vector and unit tangent vector are perpendicular to each other, which means that the dot product is 0. So here we have our unit normal vector when t is 0, we have this, and in the previous one we have unit tangent vector, which is 1 over square root of 3i plus 1 over square root of 3j plus 1 over square root of 3k. Okay, now let's see. Let's say we take the dot product between unit tangent vector and unit normal vector. So here we have 1 over square root of 3i, 1 over square root of 3j, 1 over square root of 3k, and dot that with unit normal vector when t is 0, which is this. Okay, so we have negative 1 over square root of 2i, square root of 2j, 0. So from here we get this is equal to negative 1 over square root of 6 plus 1 over square root of 6 plus 0, which is equal to 0. So you can see here that unit tangent vector and unit normal vector are perpendicular to each other, okay, because their dot product is 0. Alright, so that is how you find unit tangent vector and unit normal vector, and all of them you just need to use the formula. So oops unit tangent vector is r prime divided by magnitude of r prime, and for unit normal vector it's t prime divided by magnitude of t prime, and they are orthogonal to each other. Alright, thank you.